take more than 30 minutes. So here is
30 minutes ही आज करते हैं हाँ.
Yeah. So you know about pandas?
हाँ, I know pandas.
Pandas,
To some
I
extent.
give you a very brief one-liner about pandas is that pandas stands for panel data. And panel data,
Okay.
panel data looks like this table over here. Like we read a CSV file, tabular data, then we do a DF on the data frame. We are calling df.head to view what we have loaded inside of our panel data, our data frame. So after this step, this workbook has been created to predict the price of houses in a residential area in Bangalore.
Okay.
Before we start with actually running a model, we have to do few checks on the data set itself, like whether the data, we have to do cleansing, EDA, exploratory data analysis, like if we need to improve on the data itself before we pass it to a model to learn from and make predictions. Now, as part of that, first we have tried to figure out if we drop our null values, not this NaN values, if we try to drop them, what will be our count? So initially, if we see that DF has a shape of 13,320 rows and 9 columns, then if we copy it in second data in a new variable and then we drop the null values and not null values, then we see that we are reduced to roughly half the previous count, that is 7,496. Now, but if we do this, then we see we are losing a lot of data. So we don't do null reduction. We don't drop null values this way. What we do instead, we drop the null values on a column from size. Size is a column in our data frame and data set, and based on that we drop the null values, and then we check that shape is not affected very much. It's come down from 13,320 to 13,304. Then we do create a column called size num. Now what is happening over here, our size is 2 BHK, 4 bedroom, 3 BHK. So we figure out that we can convert it into number. And size there's also an ordinal significance in those numbers, like 3 is greater than 2, 3 is greater than 2, and 3 BHK is greater than 2 BHK. 4 is greater than 2 and 4 BHK is greater than 4 BHK. So that does not affect our computation. We have to keep that in mind while replacing a column.
So without that value, sorry for interruption. So without that value, we consider here, or we put any?
Yeah, we are putting markers. This is called list comprehension. And
what is that list comprehension?
List comprehension is a way to create lists from a new list from is a shortcut way to create new list from an existing list. So for example, if you have a list L, then you can parse I for, like, let's say you have a function also and you run a function, call the function on it, and function on I for I in my underscore list. So this will give you a new list that has been modified that is modifying all the elements of my list I and applying the function, the modifier, and then creating a new list. This is list comprehension.
Okay.
Now this is, one second, I'd show you for your list comprehension. This is a good link. It offers a shorter syntax, like it explains. List comprehension offers shorter syntax when you want to create a new list based on the values of an existing list. This is a brief brief about list comprehension. I'd share this link with you in case you want to do further reading, and then we're back to here to our. So this is one of the, I'll share this notebook with you to take a look. This is part of EDA.
Mm-hmm.
Like we have size column, we are reducing it to size num. Then we have availability column. Availability column is that,
Exploratory data analytics. Okay.
yeah, exploratory data analysis. Like we have availability column. Availability column has two kinds of values, a string and a date. Now dates are very, this is these are the unique values in the availability column. What we see is that we can reduce the availability column into a binary flag, where it says if it's ready to move, set it to 1, otherwise set it to 0. Getting it? So we are not
Mm-hmm.
bothered about to ease
Mm-hmm.
our, just to make computations easier and get to the regression part fast. We have done a rough EDA. We're not very sophisticated techniques are used in this EDA. Very rough techniques are used. Like for availability, we have simply said if it's ready to move, you set it to 1. Again, using the list comprehension syntax.
Okay, and
Availability
if it is
num.
not ready to move, in that case, how we
Then
will
it's
be
0.
considering this EDA?
0, 0, 0.
Oh, okay.
This availability column
Okay, okay.
is
So
0.
based on this column.
Yeah.
Mm-hmm.
So now
So
if
in
we
exploratory data analysis, what exactly we will be doing? Is it means we will be comprehending based on
explore,
the whatever the
yes.
data is available?
Yeah, we explore whatever the data is available to us, and we check if what, so data, let's say you get a data right over here, you saw a couple of things in this few minutes. Like we could have null values, we might have null values in our data. What do we do with it? How do we deal with them? Should we drop all of them, or should we drop some of them? Like we didn't drop all of them,
Mm-hmm.
we dropped on the size column only, based on size column. And what
Okay,
about the
okay.
other columns such as availability, which we could convert it into number,
Mm-hmm.
so that it could be passed on to a algorithm that works on numbers, like linear regression, because we are going to study linear regression. So I change availability from string to a number, a binary flag of 0 or 1, where 1 stands for ready to move and 0 stands for not ready to move. And we can do a df dot head, parenthesis open, parenthesis close again, to look
For the
like,
first five values, yes, yes.
yes, yes.
Mm-hmm.
Then
Yeah, df dot head
society,
and df dot tail is for the last values, right? Df dot tail.
yes, yes, df dot tail is for the last 5.
Mm-hmm.
Now
Okay,
we
fine.
have used, now we have a society column, and for society also we are seeing that either the society column has a value or it doesn't. So roughly 5499, that means roughly 5500 values, 54 or 5499 values are null in the society column. So that means that either null means that
Okay.
either the data collected did not know about them, or they are not part of us in society, those houses are not part of any society, or we don't, the data collected, the surveyor did not know if this society's name may be, or maybe it has taken the null value, it has been passed a null value by mistake. So any of these instances could happen, but the whole gist is that it's, if it's null, we again do a binary computation. If it's null, then we set it to 1. That means we are trying to predict, we are trying to uh, uh, assess if whether or not the house is in a society. If it's not in a house, if it's not in a society, then we set it to 1, and if it's in a society, we set it to 0. So society num, again we have a column with ones and zeros, and then we do our required columns. Required columns are those which we need from our dataset, and we drop two string columns, which are area type and
Mm-hmm.
location. Area type and location we drop, and we take our total square feet, bath, balcony, price, size num, availability num, and society num. Price is our target value that we have to predict.
Okay.
Now total square feet over here in this line is piece of code. We're in this piece of code we are working on total square feet, like it's supposed to be number total square feet, like some kind of value with the unit of square feet, but that is not the case. We saw that it is a string value with some kind of other characters and numbers such as spacebar, dot, p, s, a, c, g, etc., etc. And after removing all of those, we convert the remaining float part of the initial float part of the string to initial numeric part of the total square feet column to a float value, into a float value, and reassign it to total square feet, and then we get the required columns again. And now after dropping the null values from all the
Ashish, sorry for the interruption. So here, what you are doing is from the total square feet value, you are removing the
yes, so
216 line.
total square feet, you look at this total square feet, this looks like numeric, right? But it isn't. Later down later in the data set, there are some columns where total square feet is taking some string values, like we are over here seeing. It might have space, it might have a dot, it might have a character p, s,
Okay.
a. So this is like data cleansing of total square feet. We have to cleanse the data total square feet,
Okay, so we are removing those details from
string
the
parts,
total
and
square value column. Okay.
yeah, and then
Hmm.
getting it. Now, after doing all of this cleansing, we again try to drop null values and not applicable values, and we see that our dataset had, after bit of data cleansing, a dataset at 12.9k values, which after dropping nulls got reduced to 12.4k. So this is acceptable to us. Then we go ahead and try to create a test dataset and training dataset. So this is based on the random package shuffle method of random package, where it we create a list of size of the data frames, number of rows that are in the data frames. So it's like 0, 1, 2 till goes till the number of rows in the data frame n. Then it shuffles those numbers, like puts them in different jumbled order, and then on that list we say that 80% of our data set should be in training data set and rest 20% should be in test data set. This is the syntax for slicing the list. Here we are slicing the list. Then we are seeing over here that our training data set is 9951 rows and our test data set is 2488 rows. Then our training columns. Then
The
comes
df underscore 2,
was a
Ashish, the
copy.
df2,
Yes,
what
yes.
is
I'll
that
scroll up.
detail?
We did it to get the required columns. Our original data frame has 2 more columns, like we can see over here, area, type, and location. So we instead of dropping those columns, we created a new data frame with only the required columns. Required columns are total square feet,
Okay.
balcony, price, size num, availability num, and society num. Now, if we go down, we see that we are trying to, after splitting our data, we have a way that comes from stats models. Not just like I was telling you yesterday, it's not just one package that implements linear regression. Stats models is one package that implements linear regression, and it gives a good description of it also. If we call the model dot summary after dot fit method, and r squared is the goodness of it would take a separate session, I think, to explain it to you in short, in a quick way. R squared, adjusted R squared, F statistic, and
No,
prob.
if it takes some more time, now let us do it tomorrow then,
Yeah,
because
yeah, yeah.
today I
So
have
I
some
just
important
give you brief.
project related
I
work. Yeah.
I'd give you a brief. This is roughly complete. About to finish. Just give you a brief few liners about one liners is that it's these metrics are telling you how good your model is, how good your model explains the variance in the data set. It means that you have a suppose you have some data set like this. If you have, here is a data set, here is a data point, 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 here is a data point. Now if you draw a line like this over here, it will, your line is not a very good fit for these data sets, these data points, because it has got some errors. So it does not completely explain the variance in the data set. But let's say you have these data points, this data point is there, this data point is there, then further down the line this data point is there, this data point is there. So if we draw a line like this, then all of the variance is completely explained by our model, our line, while in this case it isn't. So this is a brief about, this is brief about what goodness of fit is, goodness of how we, what these parameters are trying to tell you over here. All of these statistical metrics are about goodness of fit, and to tell you whether your model is explaining the variance in the data set. And then 0.61 is a decent value, it's not a very good value. But then just for
So this is the value we are considering, is it 0.061
you have
r
to,
square, or it is coming result
it is
after the?
coming after fit method. We
Okay.
can improve, so we have to, if you want to do a better, if you do better at your data cleansing and all that, you might get a value higher than 0.6014 r squared, and that means that your model is very much explaining the variance in the, your model is like this is this scenario in your model instead of this is like bad fit. We just call it bad fit, and we just call it over here
Good fit.
good fit.
Okay.
R squared is just telling, so 0.6 is decent value. If it's 1, then means it's a very good fit like this. If it's 0.6, maybe something like this. It's not a bad fit, it's decent value because it's greater than 0.5. If it's 0, that means it. Then there are other statistics also, we can cover them later. But there is another thing, that linear regression also comes along with sklearn scikit-learn package, and this is a piece of code over here. It looks similar to that. We have a mod, we instantiate model, we call the fit method, then we are on the model variable, we call some parameters, like it has got some parameters like score,
So
coefficient.
where is this particular sklearn package is used for what purpose?
For machine learning, linear regression, it's
Okay.
apart from just linear regression, it has got a lot of, almost quite a lot of implementations of other machine learning algorithms as well, such as binary decision trees, naive bayes, logistic regression, knn, k-means, for multiple n number of tasks used for machine learning, for n number of machine learning tasks used. Now I was trying a couple of more things. So there is scipy stats dot linear regress also, but it was giving some error. And there is a polyfit and polyfit also. So
Okay.
these I have to explore, but to give you a very high level view, you can implement linear regression for your project using sklearn or stats models to get a head start. So, and I have explained
Okay.
goodness of it, which was left yesterday. And before, and today you learned that before doing, actually passing your data to the model, you have to do the EDA, exploratory data analysis, and in which you clean the data, you filter out, you correct some values, you filter out wrong values, you change, modify, transform your data to make it suitable for learning. So
Okay. All
that's
right.
all for today.